everyone, and welcome to our webinar today. Thank you for joining. Our topic today will be powering personalized search with knowledge graphs. And we've got two speakers here who know the space of knowledge graph ontologies and personalization as good as anybody in the business. I'm very honored and pleased to be joined by Seth Early and Peter Crocker. My name is David Scribella, Managing Director with Early Information Science. Seth, Peter, you want to say hello really quick?
Sure. Hi, everyone. Seth Early, as Dave said, I'm still founder and CEO of Early Information Science, been in the space for 20 plus years. For some of you who may not be familiar with the organization, we're a professional services firm. You can also see that I wrote a book called The AI-Powered Enterprise, and we're making that book available to folks if they'd like to get a digital download, provide that information. Peter?
And I'm Peter Crocker, co-founder and CEO of Oxford Semantic Technologies, where I'm very fortunate to work with sort of talented people, and we build a product in this space, RDFox, and that can be used to power much of what you'll see today. So pleasure to be with you this afternoon, evening, or morning, depending on where you are in the world.
Great, thank you, Peter. So a few housekeeping notes before we get started. We wanted to say thank you to our media partners, CMS Wire and Marketing AI Institute. Please check out their websites. And as always, we're happy to partner with them. And they bring some of the best content in the space of digital marketing and all things related to digital content management and taxonomy and information architecture. We are currently recording the session. A link to the recording will be sent right after the webinar, and the recording will be available on the Early website at early.com. Our session will be about 50 minutes. We want to leave some time at the end for Q&A. Please feel free to use the Q&A feature in the Zoom, and we will try to get to your questions as they come through. Your input is valued. We have 3 polls, so we do encourage everybody attending the webinar today to participate in our polls. And we would definitely like to follow up on some of the responses we get. So with that, let's dive into the agenda. A couple of sections. We want to talk about personalization and the information framework needed to support it. There are lots of foundational components that are involved in making personalization an effective experience for your customers and for your employees, and we're going to walk through some of those critical foundational components here today, and how knowledge graphs are applied to improve the search experience. So as we talk about personalization and personalized search, what does that mean, and how can knowledge graphs help enable that? We're going to talk through some specific details of how that all comes together. And then if you're new to the area of personalization and knowledge graphs, and you want to think about, okay, this looks like something my competitors are doing or we've been talking about, we'll walk you through a couple of steps on how to get started and build a program. So our first poll today is really about personalization. Before we dive into all of the gory details, we want to hear from our attendees. Where are you in your personalization efforts? Are you just getting started? Have you started to deploy limited proof of concepts across the organization? Do you have some success stories, but they're deployed in siloed applications, maybe departments that are a little bit more aggressive in their personalization? Or are you really operationalized throughout the customer journey, meaning personalization is something that is really part and embedded in every stage of your customer lifecycle and journey from start to finish? And the poll is open.
If someone asked the question of getting a copy of the recording, absolutely. You'll also get the slides, so that will be available for folks. And usually the distribution of this works out pretty predictively. A lot of folks getting started, very few at the far end of the journey here in terms of fully operationalized, but that's great. Lots of POCs, lots of pilots, lots of experimentation. And then, of course, there's deployment in silos and very specific types of applications. So that's not terribly unusual to see that. Looks like things have slowed down a little bit. So if you want to get your other questions in, any other responses in, please do. We can go ahead and close that out and share the results. Okay. So looks like about half of the respondents are really just getting started. So it's a green field for a lot of people. So we'll keep that in mind as we progress here. But there's a lot of opportunity, clearly, and we'll talk about what you need to have in place to make this stuff work. Terrific. Here results. There we go.
All right.
Okay. All right. Let me keep going here. So, Dave, I think I wanted to get started here with this first piece and talk about a framework that we need. And when we start looking at personalization, it's been a big promise for a very long time. But there's a lot of great vision, but the reality is still far from what's possible. And really, you get a lot of simple types of personalization initiatives where people who bought this have also bought that, or you've expressed some interest in a product, then you get remarketed, and that same product. Even if you've already bought something, there's an assumption that you want to buy. You bought red shoes for your wife. You want to keep buying red shoes. So these types of retargeting and remarketing efforts are not great. But to do it right, to really be effective, we need to really understand that customer and their needs in very granular detail. Some time back, we had done an information architecture project for a customer that wanted to do personalization. And so the architecture worked out very well. We built all the personalization parameters. This was handcrafted personalization. It wasn't automated, but it was simply segmenting their audiences and then deciding how to present specific content to different types of users and different types of segments. And at the end of the day, they were asking this question of, okay, how are these audiences really different? How are our personas different? What do we need to present in terms of differentiated messaging? And they couldn't answer that question. So they had the infrastructure, they had the capabilities, but they did not understand enough about that customer to really determine what they needed and how to differentiate the messaging, right? So that's a big process issue. That's an understanding issue. That's not understanding the customer. So that is a critical piece of this. We also need to kind of look at their interactions and look at how they respond to things. We call it their digital body language. We need to monitor that in real time and near real time. And we're going to get into that in a lot more detail a little bit later, but it's basically trying to read them, just like a salesperson, or you're in a physical face-to-face situation, you're reading people's physical body language, right? Are they listening to you? Are they paying attention? Are they engaged? Are they asking questions? Are they looking away? Are they looking over your shoulder at the conference for the next person they can talk to? But we have to monitor that in the digital world, right? We have data that indicates how people are responding and how engaged they are, and what they're interested in. So we need to be able to monitor that. And then we need to be able to respond to those signals, to that digital body language with content, with product, with information that aligns with their mental model. What do we mean by that? It's understanding how people go about their task, understand how they go about their wayfinding, or their information seeking, or their purchase process, or their problem solving process. We need to understand that, and we need to be able to build an information model that aligns with that, so that we can predict what they need, and we can do things. And when you go to a website and you say, wow, this website's great, they have great selection, and I really understand what they have, and boy, I love these products. That's because it matches your mental model. They use terminology that's meaningful for you. They have products that are aligned with your tastes and your interests and your objectives and all of that. So that's really getting that understanding of that user's objectives and mental model, and then aligning that with the digital model that we're building in our technology. And of course, we have to have the machinery to do this at scale. I mentioned how that one organization was doing it in kind of a handcrafted mechanism. Well, we have to be able to orchestrate this and do it at scale with the machinery, with digital machinery, because acts of heroics will not scale, right? If you try to do this with people, building these things in an artisan fashion, it's not going to work, because you can't get to scale at that. And having clean data, having consistent, harmonized data across your different tools, your channels, your applications, your touch points, that's a price of admission. Now, we also look at personalization as a recommendation, right? It's a recommendation engine. You're trying to make a prediction based on what someone has told you. This is what I think you need based on what I know about you, based on what your signals are indicating, whether it's a search phrase or term or navigational construct or the click streams. But based on what I know about you and based on what I know about similar people, I'm going to predict that you need this next. I'm going to make a recommendation, the next best action, the next best piece of content, the next best product. And that is based on, again, a recommendation or a prediction. I also look at this, we're going to be talking about this from a search perspective specifically. I also look at search as a recommendation, right? Search processes a signal. What is this signal? It's a query. It's a phrase, a search phrase, a search term, and replies back with a recommendation, a result, a prediction that's based not just on the search phrase, but other factors. There's other weighted factors, such as, Google will take 200 signals to inform the results that you see after you make the query, after you send in a query. So the question becomes, what are those factors and what are those other signals that we can take? Because in fact, search terms are very short. They're ambiguous, and they're an approximation of the search's real information need. I've been saying this for many years, and I love it. I love it so much I say it twice. Search terms are short. They're ambiguous. They're an approximation of the searcher's real information need. People think they have an idea what they want, but that search term they use is very inaccurate. It's very ambiguous. It can be very ambiguous. They want a precise result, but they think with ambiguous terms. So what do we need to do? We need to enrich that in some way. After we process a query, we can also think of this as a conversation. If somebody asks you a question that's ambiguous, you're going to ask for a clarifying question, right? Well, what do you mean by that? You want some content? What kind of content? You want policy information? What kind of policy? You want some kind of a tool? What types of tools are you looking for, right? So in that conversation response, that clarification, that disambiguation is in the form of filters and refiners. So again, I give you I put in a query, and the system will return back a set of results with filters, and the filters are asking for clarification. It's like walking into a hardware store, and you walk up to the counter and you say tools, right? And what's the clerk going to say? Well, what kind of tools you're interested in, right? That's an ambiguous query and a clarification question. So if we do the same thing on a website, we put in tools as a query. Well, what kind of tools do you want, right? That's the disambiguation. That is the conversation, right? That's how we're trying to get clarification. And as we do this and we put in another clarifying parameter, we'll continue to have that question. We'll continue to have that interaction. It's a matter of retrieval and exploration. People, when they think they know what they want, they will search and retrieve. When they don't know what they want, they'll discover and browse, but you actually shift back and forth in the same session. If a person is walking into a store, hardware store, and they're wearing coveralls with paint on them, and they have a hat labeled Joe's Painting, you might infer that they're a painter, right? And so if they walk in and say, I need supplies, you might say, maybe you want painting supplies, right? The signals about that person and their physical body language informs that conversation. In this case, it's that appearance that's giving us those cues, right? Those clues about what's important. So again, supplies, and based on your appearance, I think you might need paint and supplies, right? So in the digital, that's what happens in the physical. In the digital world, we have lots of other signals. We get lots of digital body language. It's represented by metadata. It's represented by the signals and the data that are kicked off by different touch points as we interact, as we respond to a campaign, or as we click through on a website. That's producing data about the user. That's giving us that digital body language. So we can capture that in the form of a graph. And we're going to talk about what a knowledge graph, what a customer identity graph is, and so on. But what we're doing is we're capturing it in a model that's representative of the user. And we'll see there's lots of different ways to do this, but we're trying to understand more and more about that customer as they go about interacting with our systems and our processes. So digital body language is metadata. It's the metadata about that customer and about those interactions. That metadata can become the additional signals that the search engine can leverage that produce more accurate and precise and personalized results. So search algorithms, when they use metadata to retrieve information, right? The signal that you're providing, the search query, but they're also deriving metadata about the content. Even when you don't have metadata, it is always about metadata because the search engine will derive metadata. It looks at the content, it builds an index of that content, of the words that are in that content, it inverts that index so you get the content or the documents for particular search phrases. But then there's also other metadata that will inform that. So we have another, Dave, I'll let you introduce this one. So another poll.
Sure. So as we think about personalization and we start to tie it to knowledge graphs as a supporting technology to really pull some of these different areas and components of a personalized experience together, we want to just ask the attendees today, how familiar are you with knowledge graph technology? Is this something that is on your radar in your job or personal life? Is this something where you actually have started initial research? So maybe you understand what the technology can do, but you're not really sure about the landscape and how it might fit in. Maybe you're a little bit further along. Are you starting to deploy proof of concept or pilot applications to really take a knowledge graph technology, a knowledge graph database, and apply it to real world business problems or operational problems? Do you have proficiency in your organization and are you starting to integrate it more across the enterprise? Meaning knowledge graphs are starting to tie together actual application and functional use cases, and you're starting to see the realization of a knowledge graph bringing together disparate data or content sources.
So it looks like about a third. We still see the analogy here is popcorn popping, right? Starts really fast, then it slows down, and then you start to smell the popcorn burn. I don't think we're at that point yet, but looks like it's slowing down a little bit. So pretty reasonable distribution between the first. The first few. Some are not on the radar yet. Others started initial investigation or doing POCs and deployment, and very few are really at that level of maturity. And this is an important technology, so it is something worth investigation. There was a quick question here that I just wanted to answer in real time. Personalization assumes you have all the information and data required that helps you understand your customer. Assume that's the longest part of that journey. Yeah, and it's never having all of it. It's always having pieces of it. Right? It's building it incrementally over time. If you know what industry someone's in, that's one piece of data that you can begin to act on. But if you have more information about their role, more information about, their particular interests and so on, you can start to add to that. So it's an ongoing journey. And as you say, getting that understanding of that user and those customers are really, it is the longest part, but it's a never ending part. So that's why when you start looking at things like first-party data programs where people are beginning to capture more information about their customer. I've heard stories of, consumer products companies that would get surveys and throw that information away, or they do field promotion stuff at stores and they just wouldn't save any of that. And, that was kind of an earlier time. We're trying to save everything now. We're trying to capture and build those repositories to understand that customer in great detail and build that 360-degree view of the customer. More important now than ever, because we don't have the same rights to we can't get third-party data the way we used to be able to. And cookies are problematic, and some of the policies of the large platform vendors are changing. So again, we need to start thinking about how we can get that information. Okay, so I think we shared all of that, and that's so. Let's keep going here. Okay, so the next thing I want to do is kind of connect the dots between, when we talk about knowledge graphs, what are they? People are familiar with taxonomies. They're familiar maybe less familiar with a thesaurus or an ontology, but let's define each of those things. So we start off, the building block of a knowledge graph is a taxonomy or multiple taxonomies. We never have one single grand galactic uber taxonomy in an organization. We have multiple taxonomies. And which you can see in a taxonomy is just a parent-child whole part type of relationship. It's, I like to say hierarchies are for humans, right? Computers don't care about hierarchies because they can deal with big, long lists. Humans like hierarchies because it helps with the mental model, it helps you group things and understand what to expect. You can kind of infer what you might find on a website if the categories are clearly defined. You may not know exactly what you're looking for, but you kind of start knowing where to go. But when you look at these two hierarchies, one of the things you observe is that, it's not necessarily the same as navigation, and they serve different purposes. So if I am a customer and I am looking for Monopoly, I don't really care whether it's Milton Bradley or Parker Brothers, and I don't know. And I know it's a board game, and that's where I'm going to look. But if I'm a brand manager, I need to know what brands I'm managing. And so a brand hierarchy is probably helpful for me. So it informs navigation, but it's not the same as navigation. We also have other types of relationships. When you have multiple taxonomies, we start building out a thesaurus structure. And a thesaurus is a taxonomy on steroids because it includes things like preferred terms and non-preferred terms. So imagine that statement of work is one of our terms, and proposal is another term, and SOW is another term. And if those are if those are the same thing in terms of my usage, now again, someone might say, well, proposal is different from statement of work. If that's a meaningful distinction and difference, and it's important, and I have a use case that says, oh, I need to separate those out, fine. But if the difference is not meaningful, if it's a minor distinction, certainly SOW and statement of work, those are equivalents, right? Those are equivalent terms. Those are synonyms. But proposal and statement of work could also be synonyms in certain circumstances. And then so we have that equivalence term. That's very simple. We talked about the parent-child, the whole part, hierarchical. And then we have something called associative. And this is where things are conceptually related. So if I have a hierarchy of products and I have a hierarchy of services, well, what services go with that product? Or if I have problems and I have solutions, what solutions do I have for those problems, right? Or what products fit in with those solutions? What software runs on which hardware, right? You have multiple categories and multiple vocabularies, and you have relationships between them. And this is what forms the triple, or this is what can form the foundation for an ontology. We also have the ability to infer these relationships or compute these relationships from data sources. So there's a human judgment piece of this, but there's also a computational piece of this. So if you can think of any relationship that you find meaningful, you can have it. That's how powerful associative relationships are. It's just conceptual relationships between these things, but we can also do a lot more with them. And Peter is going to talk about a little bit later. So here again are the soundbite definitions. Taxonomy is a list of terms that enable classification, whole, part, parent, child, subject, topic. It gives us context. A thesaurus is a taxonomy on steroids. As I mentioned, it includes the equivalence relationships and the associative relationships. An ontology is a collection of all the taxonomies and thesaurus structures and all of those relationships. So it covers a domain of knowledge. So if I'm talking about life sciences, it's mechanisms of action and biochemical pathways and diseases and indications and routes of administration and routes to market. It also has marketing stuff. It also has content types. It also has, customer types and regions and all sorts of other things, right? It's all the things that you need to describe your knowledge domain. And then we have the ability to use those relationships to start to do some kind of inference or reasoning, semantic reasoning involving the understanding of terms and the understanding of conceptual relationships. And again, Peter is going to talk a little bit about that a little bit later. So here's an example. I'm just going to walk through an example of taxonomies and then a ontology and then a knowledge graph. But essentially, here are the taxonomies for an industrial distributor. And you can see, these are parent-child relationships. Even if the vocabularies are flat lists, the top-level term could also be considered the metadata field, right? The type of descriptor, but it's also the top term of the taxonomy. So here are customers and here are all our customers. That's a hierarchy, right? These are the types, these are the customers. Here are our products and our product categories. Here are the industries, the processes, the environments, the tasks, the roles that customers have. So again, we're describing all of these elements of our world, of our domain in this particular field. And again, it includes all of these different things. Now, when I start mapping out those relationships, those hierarchical relationships, the equivalence relationships, the associated relationships, this is where I can begin to map out those things that are conceptually related. And this is where I can start to do inference. I can start to look at related content. I can start to look for different ways to navigate our information sources, both structured and unstructured. And I do that in terms of a knowledge graph. So in the knowledge graph, it actually takes that scaffolding, that ontology is the knowledge scaffolding, right? It's where we kind of hang all of our knowledge and content and data. It's a structure. And then what we are doing here is we're relating that to the actual data itself. And that's when we get a knowledge graph. And knowledge graph contains the operational and transactional data with the access points of these concepts. And it allows us to be able to have lots of different ways of looking at this information. It allows us to look at, well, let me look at the roles in this customer and let me see what kind of interests they have. Well, let's look at the processes related to those interests. So again, you have the ability to navigate this web of relationships and this web of knowledge within the organization. And it gives you a lot of flexibility in terms of how you can retrieve information and act on that information when we have these types of relationships. So the ontology is the scaffolding, the knowledge structure that you hang your knowledge on, you hang your content and your data on. It's consistent across the organization. It's the semantic framework, right? It maps different things together and allows you to take different ways of naming things and then map them together to a common lingua franca, right? Common vocabulary, common language, common semantic framework. And then that knowledge graph builds that scaffolding in with the data, right? So, Dave, I'll turn it back to you.
All right, time for our next poll. So based on what we just presented around knowledge graph technology, thinking about that semantic layer and framework, we just want to open it up to thinking about the application in search, right? So search historically has had specific ways of interacting between the search engine and the person entering that query, but knowledge graph opens up new opportunities. So if you could think about how can knowledge graph technology most improve search, maybe you're not sure and need a little bit more information. Maybe you can think about its increased ability to integrate disparate structured data sources. Or maybe it's about the increased ability to take all of those things in that scaffolding and bring them together, whether it's structured data from a CRM or ERP and unstructured content and information from lots of different sources. Maybe it's just about having the semantic richness to really enable more natural language ways of searching. So the searcher doesn't necessarily have to think about the right keywords to optimize those results. It can really interact with search or knowledge retrieval in more natural ways. Something else altogether that we haven't thought about. And those responses, we'll definitely want to try to call on those people at the end of the session to get their ideas there. But
nobody's indicating that.
Okay.
Let me go ahead and end the poll here for now, and then we can share those results. And you can kind of get a sense of, a lot of folks are really not completely clear on this, right? We didn't give you a ton of information, so that's fine. That's understandable. But it is really about these things, natural language searches, right? When we can start to, one of the problems is with search is a lot of what we're trying to do with AI, machine learning, is make up for our past sins in poor data hygiene, really, right? When we start to look at what we can do with natural language search, we're saying, I don't know how you tagged that content and I don't know how you structured it, but I want to ask this English language question here. And we have the ability to start mapping those things together and do better natural language processing. And again, integration of structured and unstructured. The project that we did at Applied Materials at Harvard Business Review article you guys haven't seen that, just send me a note. We can get that to you. It's saving $50 million a year, but it was exactly that. It was integrating structured and unstructured information. And rather than going to 14 different places, it was a search interface, leveraged an ontology and a knowledge graph behind the scenes. And it allowed, these field service engineers to find exactly what they needed when they needed it and reduce that time spent looking for the information. So there's a lot of great things that we can do with this. And you're hear even more of that, Peter. I just want to give you one quick example of how this works with search. And then, when we have an ambiguous query, this is where that digital body language comes into play, and that understanding of the customers and their characteristics and their interests and their roles. If I have this term of mold stripping, it's an ambiguous term because I don't know if that's the black stuff that I have to strip off of a wall because of the flood, or if that's an injection mold that I need to break down and prepare for the next run of whatever I'm doing, whatever I'm molding. So the question becomes, is it mold and mildew remover, or is it something else? And so here, in this case, if I understand something about my customer, if I understand that from that knowledge graph, right, from that customer identity graph, I'm using those interchangeably. When it's focused on a customer and customer attributes, we call it an identity graph, which is part of first-party data. But if I know they're in manufacturing, I know they're an engineer, maintenance engineer, I know they're interested in processes or fabrication and the tasks or equipment maintenance, I can infer that they're looking for stuff around injection molds, right? So now we're going to kind of take a deeper dive into what else we can do with this, and then we're going to come back to it and talk about specifically doing this with search. But this customer identity graph, as you could see from that prior knowledge graph and ontology and that I had shown you before, we can start to look at all of this digital body language. We can start to look at this history, service history, what industry and the campaign responses, the products that they've purchased, their demographics, their installation, all of these things. And these can get quite complex, right? They can have applied, inferred, derived, explicit, implicit, all these different types of metadata. What this is it's describing their context. It's describing something about them. It's identifying that digital body language. And it can be fast moving and it can be slow moving. It's stuff that can change very quickly or change very slowly. Like we don't change industries a lot or fields, but a campaign response is going to be real time and it's going to change very quickly. So we collect these signals that are throughout that customer journey from all of those different touch points. And we can start again looking at this and acting on it. How do we do this? Well, we create what we call a high fidelity journey map. What is a high fidelity journey map? It's understanding the customer needs in metadata terms. A lot of times when you get journey maps, customer journey maps, they're great, and they give you lots of insights, but your systems can't act on that. Your systems can't act on those pretty pictures. What we have to do is convert that into metadata, like something that describes their intent or their journey stage in metadata terms that I can capture in an identity graph that I can then act on. So this is what we're going to talk about now. So we understand that journey, we understand the details of the customer, and then we define the content that they need. And so here's how it works, right? When we start looking at this, there's a number of different components. We talk about, content architecture, content operations, customer data, product data, and then knowledge architecture. Those are our 4 pillars, but they all fit in very well here. We start off by understanding the customer. What's that customer data model, right? And this is where I talk about, what happened to my animation got broken. It's supposed to nicely glide down and shrink down there. So I don't know what happened. But anyway, the point here is that this consists, I'm calling this static metadata. It's slow moving metadata. It's the interests, the roles, the firmographics and so on. We also have things that happen real time. Each time I do something, it changes my metadata model, and I can collect that in a customer data platform. All my animations got a little mucked up here, but that's okay. But the point here is every time I do something, I am changing that metadata model, right? The dynamic customer data model is real time. That's when people are responding to campaigns, they're clicking through recent purchases, any of those new goals, any of those activities changes that metadata model. You can see that little pink box that changes. So this is how this works. So when I download a white paper, you can see it changes that this is the high fidelity journey model. It's describing their actions in metadata terms. So when we download a white paper, that's top of the funnel content, right? That's from my knowledge architecture. It gets consolidated by customer data platform or by a knowledge graph. I then use that to inform my product information management system and my content management system, and I make a recommendation. I provide a product recommendation and maybe a new offer. Again, as I go through each step of this process, now I compare products. Our knowledge architecture from expertise from our subject matter experts, our brand merchandisers or product specialists, see that's middle of funnel content. And same idea, I'm able to consolidate that, and I'm able to make a recommendation about product or about content. And the same thing here, download installation guide, that's post-purchase content. And the same thing happens. Each time I do this, I am taking that signal and I'm using it to inform what I'm doing. The same thing with post-purchase content and nurture content. So again, this is the idea of acting on that digital body language. And we can use this for search. We can use it for dynamic content. We can also use it for bots and virtual assistants. It's the same principle. So that's kind of where that goes. And again, you need a lot of different pieces to this. This is really for your reference. I'm not going to go through all of this, but models. You need the unified models. You need the customer data models. You need the content models. You need the product data models. You need that insight and expertise from the specialists. You also need tools and processes and some services or expertise. Again, this is for your reference. You can read that later. Okay, I'm going to, Dave, that's my section, so I'll turn it over now.
Yeah, we've got a couple of questions in Q&A, but I want to hold them until the end. So with that, let's get into Peter's section on knowledge graphs and the application to search.
Thanks, Dave. Thanks, Seth. Okay, so in this next section, we're going to be showing an application for some of these concepts and specifically looking at search. So let's dive in. And this is a multi-step process where I've broken down the different parts that fit together and provide this much far richer personalized experience and recommendations to our users. So first, we need to unpack the search term. So as we saw earlier in the visual that Seth gave of the final search, we obviously receive a search term. Typically, this is going to be text entered by the user, and it carries all of those aspects that Seth was talking about: ambiguity, approximation to what the user's actual intent is. And they do so perhaps consciously, perhaps unconsciously, based on the experience they have. This text is going to match, we hope, specific products and certainly categories of products within a product catalog. And this is where our first technique or tool comes from the semantic toolbox. So this product catalog arranged as a taxonomy allows us to take that text and expand it. In fact, before we go there, just searching a structure like this, a set of data like this is usually where search systems stop. And there is no personalization and nothing to deal with that ambiguity and take advantage of personalization. So everything I'm about to say from here kind of takes advantage of some of the more advanced features we're able to do. So organized as a taxonomy, it's very easy to find similar items to the one matching the search. You might have things known by a different brand name, but still match the intent of the end user. And also it's very straightforward to move down through the catalog if someone's typed in a particular catalog of product a category of product that they're looking for. With all these links, the initial list that matches that text has now been expanded. So the chance of being able to recall from our vast catalog the precise intent of the user has been increased. However, it comes at a cost. It comes at a cost of precision. We've now taken something that perhaps is returning a few tens of results, perhaps into the hundreds. And ultimately the user now has more content to look for. So we need to find a way of ordering this, of refining the way in which that expanded set is presented to address that, because clearly an expanded list of results is not quite what we want to present the user with next. So we move on to the next step. This next step comes in from the left in this diagram, and this is where the user's digital body language is brought to play. So here, what we're doing is we're taking that digital body language and we're using various features of it to align people, and the people we have, to a persona. At first, this might be coded by experts within your business who understand or can make assumptions, make educated guesses, if you like, as to what features of the body language corresponds to or matches up, pairs up an individual with a persona. And over time, as we gather more data, we can start to look at applying things like machine learning to refine that initial estimate from experts within our business. Next up, our product managers get involved within our business and rank, sorry, we're still on step 2, and rank the product categories that are important to put those personas. And again, you may not have all this information. However, this, and to the earlier question as to, what do I do if I've got incomplete information? Well, regardless of whether you are complete, this process at least gives you a starting point and a way in which your business can make its current best estimate of customers and how to rank personas and their mappings. And we can now start to address the challenges that were created with that expansion of results in the last step. So we move on to step 3, and here we start to bring that expert, that person who in the sales room was able to identify the individual as wearing overalls covered in paint. Here we're now able to start putting these two things together and put that expert in the box, so to speak. So what we do here is we combine the ranking that has come from the body language, from the persona, along with the result set that comes from our nice, neatly organized taxonomy, and use these two things in combination to provide the top categories and the top results that we believe are the best recommendations for this particular user. So it's just like having that expert salesperson in the box, looking through all of the available results that could be removed, returned from our catalog, and presenting them based on that digital body language. The final step, step 4, moves to embellishing, adding to the interface that we're able to provide. And we're all familiar with some of these aspects with our online shopping experience. And the smart thing we can do here is reuse facets or attributes that are taken directly from that knowledge graph of products, and use that same routing information that got us the results to expose on the left-hand side, typically, the facets, the controls that can be used to further refine the user, the search, and the ordering in which they want to search their results. So with all those steps complete, let me present sort of a summary of where we've got to. We have the user providing their text. We expanded that list of results with our product catalog organized around a taxonomy, and those results were ordered through the digital body language, and facets were brought in to give the user further assistance to go from that position of ambiguity to a position where ordered results are presented, to finally this place where they can refine and remove the ambiguity in the most appropriate fashion. So that was an example of how to apply graph to search and take you beyond simple text-based search into something that personalizes the recommendations in your response to search. Let me now show you a few examples of partners, customers we've worked with to use knowledge graph and semantic technology to enhance the way in which they serve their customers with recommendations.
And this was one of the other questions that popped up and saying, okay, this is valuable. What else can we do with knowledge graphs? So
absolutely. So this is a fantastic example. So here we're talking about a global manufacturer, in fact, a global manufacturer that supports manufacturers themselves in their factory setting. And in this particular example, the company involved was looking to help create an automated approach to an area that had challenged them for many times and typically involved a salesperson, technician, spending time crafting out of the thousands of components available to this company, individual solutions to bespoke problems. Semantic technology was brought in to the mix, and in particular, some of the reasoning that Seth referenced earlier. And what they're able to do is build an engine that sits within their organization to compute all of the possible ways in which their components can be combined to make solutions. They do this to, if you like, within the computer, assemble the most appropriate solution out of those thousands of components for their clients' needs. And there can be many millions of configurations. With just a few rules and those configurations predetermined, relevant search results can now be returned in real time as the user clicks through the interface that explores the world of these millions of possible combinations. So they have taken a problem that used to take days, involve humans, experts in their own right, and take all that expertise that was captured in the minds of those individuals and condense it down into rules that can now be automated and run in close to real time, with results now moved from the realm of days to less than a second. The other great benefit they got from this was internally for their product managers, being able to iterate over the possibilities that new components that they were proposing might bring. Again, being able to iterate on hypotheses, theories of components they should add into the mix, and do so in seconds rather than having to wait for the system to compute the output of adding a new component.
And I'll tell you, CPQ is such an incredibly powerful application, and it does require that you have these different relationships. It's at the intersection of knowledge management, content management, customer data management, and product information management. It really is at that intersection that leverages knowledge graphs in all of those incarnations and can provide tremendous efficiencies and effectiveness. And that can also power, intelligent virtual assistants that can be configuration bots, right? So all of these things are so interrelated, and building this core functionality and framework really opens up limitless opportunities for the organization. These are just a couple of classes of example. Did you want me to move to your next example?
Yeah, next slide, please. So here's another example, and perhaps a slight extreme example in terms of the proportions involved. So Samsung Research, in collaboration with our company, and in fact in collaboration with the University of Oxford as well, used our technology to explore a completely different way of thinking about recommendations on the smartphone. Their mission was to provide the same kinds of recommendations, or in fact enhance recommendations on the things that we carry around in our pockets every day on the mobile phone, but do so in such a way that the entire solution was running on device itself. And the reason for that was to get access to the rich wealth of information that exists on these devices, and to do so without compromising the security of what can be personal and sensitive information. So they use knowledge graph technology and reasoning to explore and combine the digital footprint of the individual with the phone in their pocket, but do so on the phone itself and have our technology running in that research to provide the recommendations directly on the device without compromising the security of that sensitive information. And we can imagine all sorts of recommendations that might come out of that, be it retail, movies, entertainment, news, and so on.
I mean, that's a fascinating application, because you're saying we're going to do this in your world. We're not touching your, we're not taking your data, we're not uploading it, we're not consuming it, we're not repurposing it, we're not sharing it. We're operating on it within the context of your device and your privacy and your world. That is really incredible. That's very cool.
Exactly. And for both of these, we have write-ups as to how these things were put together, and more of the background as to the reasoning as to why. So I'd encourage you to go to follow the links shared here and go and read some of the background information there. Okay, so that's my section done. We've gone through a quick example. Over to you, Seth, to how to get started.
So getting started in 90 seconds.
Yeah.
Right. We want to.
Go ahead, Dave.
We want to talk about the some of the steps, right? So I think it starts with a good reference architecture. We want to think about how that semantic framework, that ontology or sets of ontologies, which really inform and start to build that knowledge graph, piece together parts of your architecture. Maybe these are existing parts, or maybe these are new parts, but we encourage the activities to start to think about those sources of information and how they come together to build that overall architecture to drive some of that knowledge graph and personalization experience.
And one of the things that we point out about this is, you have to think of these from the internal and external perspective. There's another presentation that we do that talks about orchestration, and really this is about orchestration, right? It's about orchestrating the product data, the content, the customer journey, the digital body language, the signals, the knowledge. And in order to do this, you really have to have consistency of these different systems and technologies in terms of how they're structuring the information. So, you don't have to be doing advanced things to be able to benefit from getting your data house in order. So starting to build out that enterprise architecture, that reference architecture, those ontologies, those taxonomies, they will, as time goes on and you onboard new technologies, or you re-platform, or you migrate, you want to start harmonizing this architecture. And that provides tremendous benefit by allowing for greater levels of integration, less friction in processes. And I like to say, you can't expect a seamless customer experience with acts of heroics upstream. So you have to be able to fix that digital workplace, meaning making search work, making knowledge work, making your content work, making your BI work, the things that people need to do their jobs to enable the customer. So really thinking about this, not even around personalization, not even around, AI, but just general data and information architecture and data, information, and content hygiene is really one of the things that has to be done no matter what. And there are ways to do this that can help you evolve this over time.
We have a question in that sort of goes beyond that. Some of what you just touched upon there, Seth. So the question is, how are your knowledge graphs created and maintained? Are they created manually, automated, and so on? So if we take, for example, that configuration example I was talking about earlier with our manufacturing client, some of that will have been entered as raw ingredients within a product catalog system, and we would have mapped and integrated that system as a feed into the knowledge graph before the reasoning that we talked about actually constructed the world of possibilities, those millions of possible configurations. So there is a combination of, yes, the product managers and the systems that they're already familiar with, combined with reasoning to automatically expand and infer additional knowledge on top of the source data. Mm-hmm. Some of the information you're going to put in your knowledge graphs is also publicly available. So there are publicly available or suppliers that can provide you, for example, with ontologies around a topic within your domain. I was talking to a customer in the food space earlier today, and there are ontologies about food, about ingredients, about the nutritional content of those ingredients. So these are things that we can pull on, integrate with our own internal systems, and combine to get this overarching knowledge graph that is really the power and the piece that you then build on for serving your customers.
Absolutely, and I think the key there is you have standards provide efficiency, differentiation provides competitive advantage. So you want to be able to leverage standards as much as possible, but you don't want to depend entirely on standards because you will be differentiating your customer's experience. So there's a bit of human judgment in there as well. Dave, did you want to speak to this slide, or would you like me to?
Well, this is really about readiness, right? So understanding your current level of maturity and understanding where you want to go helps to really shape and inform how much work is needed across these different areas. And we talk about content and the customer data and your product data and your enterprise knowledge. Really, to get to a fully personalized experience, you're going to need to advance maturity, most likely in all of these areas. So to really get to that place where you can deliver a personalized experience, you're going to want to improve in all of these different areas.
And know what your current state is, because if you're stage one in one area, it's really going to be, it's going to limit you. So you need to think about what's appropriate given your stage of maturity and what you need to do to move the needle.
So personalization begins with a well-designed architecture. I think we talk about this, the foundational components that are critical. You can't skip them. You can't automate a mess. So you can't just throw a bunch of bad data into machine learning algorithms and expect a miracle. You certainly can't automate what you don't understand. Simplicity is hidden complexity, and there's a lot of work underneath the covers, but ultimately the experience you want to deliver to your customers is probably going to be intuitive and usable, but behind the scenes, there are a lot of moving parts, right? And as we always say, clean data is the price of admission. If you're starting with really dirty data, you're starting on the wrong foot. So getting started, we have these steps here, beginning by documenting user journeys, understanding your technology at each touch point in that journey, capturing those important aspects of customer metadata across the journey and starting to tie those to a knowledge graph, segmenting your audiences based on different attributes, ranking categories based on relevance, so understanding how some of your product information correlates or relates to those segments and that customer information. The process of seeding orchestration algorithms, right? So understanding how some of these algorithms that tie these different facets and domains of information together is important. You really need to start to curate that from the onset and think about then how to tune it and use machine learning over time. Starting simply with a few ranking elements and a few use cases is the best way to start. And of course, thinking about how to measure from the onset, performance baselines, and thinking about ongoing measurement as you start your journey.
Shampoo, rinse, repeat, continue to experiment, refine. And I know we have this framework, we don't have time to get into it, but if you're interested in getting started, we have a program that we're working on with Peter's company, and we can do discovery, we can do a readiness assessment, identify high priority use cases, and then start going through this process of picking the right use case, showing value, building ROI, and building a roadmap. And that's a very methodical process and can get you started and moving down this path.
So here are some resources, both from early information science and Oxford Semantic. We definitely recommend you check out more on these topics. And again, these slides and the recording of the presentation will become available shortly after the presentation.